Okay, so we are going to tackle part 2 of graphing quadratic functions. Now with part 2, we're going to actually um, start looking at how to graph these using the information that we get from the standard form of the equation to kind of help us graph this a little bit faster. Okay, so we are going to just write some steps down first, and then we'll go through and start working on an example. Okay, so there's just a bunch of information that we're going to write down. Normally, if we had more time, we would go through some graphs and you would see some of these things happening on your own. But for time purposes, unfortunately, we have to just give you the information. So just start copying down this info. Okay, so the first piece of information is about the axis. Okay, so the axis of symmetry is x equals negative b over 2a. So what's going to happen is when you look at the standard form, you're going to take the b and the a, and we're going to substitute into this little formula here, and it will actually give us our axis of symmetry. Next up is the vertex. So the vertex has an x coordinate, negative b over 2a, because remember, when we graphed with the table, the vertex, the x coordinate of the vertex was also the number used in the axis of symmetry equation, right? So what's going to happen is you're going to, with the vertex, you're going to get the x coordinate using this formula. Then substitute x back in to find y. So what's going to happen is you're going to take the x value that you get from this little formula, and you're going to substitute it into the standard form equation, do the math, and find the y. One more piece of information about the vertex. The vertex is a minimum when the parabola opens up and the vertex is a maximum when the parabola opens down. So with our parabolas, these U-shaped graphs, the U shape is either going to open up or open down. Okay, and what happens is that vertex is either the smallest y value or the largest y value, right? Let me underline these. So it's a minimum when it opens up, it's a maximum when it opens down. Okay, and we're going to talk more about the open up and open down, because if we want to try to graph this without so much of a table, then we need to know, is my U going to open up or open down? So to find that information, we're going to say the parabola opens up when a is greater than 0, opens down when a is less than 0. It's kind of similar to when we graphed exponential functions. When the a was positive, we had the equation graphed. For example, I'm trying to find the words to describe it, but if we had an exponential function that looked like this would be a was positive. If a was negative, we got a reflection, right? Or if our graph looked like this, if a was positive, if a was negative, it was the reflection, right? So the same type of thing is going to happen here. When a is positive, it's going to open up. That's kind of like the parent function or the basic way that a parabola looks. But if we have a negative a, we're going to get a reflection. Okay, so it's kind of a way to relate to what you've already seen before. The next piece of information, the y-intercept is located at 0c. So the c from the standard form of the equation is going to give us our y-intercept, which also makes sense because when we graphed linear equations, the constant was our y-intercept. And in this case, the constant is still the y-intercept. So you can even make a little note that it's the constant. Okay, 2 more pieces of information. Okay, the parabola is narrower than the parent graph if y equals x squared. Oh, not if yet. The parent graph y equals x squared if the absolute value of a is greater than 1. Okay, so our parent function, we still have parent functions. So with quadratic functions, our parent function is y equals x squared. Okay, so if a is greater than 1, if the absolute value of a is greater than 1, it's narrower. It's wider if the absolute value of a is less than 1. Okay, so this would be considered a stretch, and this would be considered a shrink. Okay, so a stretch makes the parabola become more narrow. A shrink actually makes it wider. Okay, when we hear shrink, we think smaller, but when you think shrink in this case, you want to think like smushed. All right, so if we smooshed it down, it would get flatter and wider. Okay, so the a determines a lot. And again, you'll see this is very similar to when we graphed exponential functions, because when we graphed exponential functions, there was a stretch and a shrink as well. Okay, and the last part, the slope a will find points on the parabola that are 1 unit to the right and left of the vertex. And you'll see what that means as we do a couple examples. Okay. It's a lot of information. That's definitely something that you're going to want to keep handy as you work. And remember, the whole time, you can use a table for everything here. Okay. Um, this is not something you have to memorize. You can absolutely use the parts of it that you can remember to help you get started, and then use tables from there. And I'll show you what I mean on our examples as well. Okay, so example 1, we're actually going to use the same example that you worked on yesterday, because I just want you to see how it differs a little bit using the information instead of just making a table. So example 1, y equals 2x squared minus 8x plus 6. Okay, now remember, our standard form is y equals ax squared plus bx plus c, right? That's standard form. All right, so the first thing is we're going to identify our a, our b, and our c, because each of those parts are going to come in handy for the different pieces of information that we just looked at. Okay, so the first thing we want to look at or think about is our parabola going to open up or open down? Is it going to open up or down? So if we look back at where that information is, right here, the parabola opens up when a is greater than 0, down when a is less than 0. So my a in this case is greater than 0, so it's going to open up. And that's because a is greater than 0. Next, we're going to look at the axis of symmetry, because that's going to be important for us to know where the mirror line is going to be, right? So to do this, we are going to take our formula, negative b over 2a. Well, if b is negative 8, the opposite of that is going to be positive 8 over 2 times 2. So we're going to get 8 over 4, which is 2. So my axis of symmetry is x equals 2. Now, if this part here got you confused, then what you can do as a side note here. So instead of that, I could have said negative and then just simply substituted here. And I would have had negative, and then negative 8 over 4 would be negative 2. Negative 1 times negative 2 is positive 2. Okay, so you could have kind of gone through it that way as well. All right, next up, the vertex. And these are pieces of information that you had to give on the last example as well. So, keep that in mind, that we're not having you do anything extra like that. These are all pieces of important information. So the vertex is going to be the x coordinate that we found up here, right? So my x coordinate is 2. I just have to find the y coordinate. And what the instruction said was substitute the x to find the y. So what we're going to do is I'm going to take my original equation here, and I'm going to replace the x with a 2. Okay, so if you think about it, if I know one of the coordinates of my vertex, all I have to do is substitute it to find the other coordinate, right? Because this is a function. So I'm going to have 2 times 2 squared minus 8 times 2 plus 6. and I would get -2. Okay, so the next part we want to know, is this going to be the minimum or the maximum? So is it going to be the low point or the high point? And if you look up above, the vertex is a minimum when the parabola opens up, maximum when the parabola opens down. We already know that it opens up, so this is going to be a minimum, right? And the last piece of information to find is the y-intercept. And I'm out of room over here. And in our list of information, scoot it up here, the y-intercept is located at 0c. So my y-intercept is going to be 0c. And the c is a 6. All right, so based on that information, let's see how much of this we can get graphed. So if you have graph paper, you'll want to use it. All right, so my vertex, that's a really good place to start, is at 2, -2. My axis of symmetry I know is going to be on this line, right? So whatever happens on the right is going to also happen to the left. My y-intercept is 0, 6. So if I look, I go 0, 6. So now I know that if my axis of symmetry is right here, right? That's my axis of symmetry. So that's like my mirror. So whatever happens to the left is also going to happen to the right. So I know that since my y-intercept is right here, and it's 2 away from the axis of symmetry, I must have a y-intercept, or not a y-intercept, I'm sorry, a point right there. Now, we do need 2 other points because we don't know enough information just by looking here to see exactly what the curve looks like, and it is important. So we're going to look at this last statement here. The slope A will find points on the parabola that are 1 unit to the right and left of the vertex. So what that's going to do is that's going to give us my point that's to the right one and to the left one. Okay, so the slope is A. So we're going to add a little note here that says slope is A, which is 2. So this will find me 1 point to the right and 1 point to the left. So what that means is I'm going to take the vertex and I'm going to find the next point by using the slope 2. Okay, so I'm going to rise 2, run 1, and there's my next point. Okay, if I know that I have a point here that's 1 to the left, I know, or excuse me, 1 to the right, I know the 1 to the left is going to be there. So that slope gets us these 2 points. And now I can connect and create my line. Now we got lucky because we were given the y-intercept. Usually you want to have 5 points on your parabola. And if we look at the example from yesterday, for the 2x squared minus 8x plus 6, if we look, I got the exact same graph. We just went about it a little bit differently. Okay, now if you feel like, well, that was a lot more work, I might as well just do everything from a table. That's okay. Just know that you will need to be able to identify all of these pieces anyway. So if you're having to identify all of this information, it might be faster to just graph it based on this information. Use a table if you have to. All right, let's look at another example. Okay, y equals negative 2x squared plus 12x minus 15. Oops. Okay, and then we're going to answer all of these questions that we had here. First, let's identify our A, our B, and our C. Then we're going to say, excuse me, and it opens up or down. So we know that it opens up or down based on the A, right? If our A is positive, it opens up. If it's negative, it opens down. So in this case, our A is negative. So this is going to open down because the A is less than 0. Okay, so then our axis of symmetry, we're going to look at negative b over 2a. So we have negative 12 over 2 times negative 2, negative 12 over negative 4, which becomes positive 3. So my axis of symmetry is x equals 3. Then for the vertex, I know that my x coordinate is 3. I have to figure out now what the y coordinate is. So we're going to go in and we're going to substitute a 3 in for the x. And just do our math. And we get 3. Now, is this a maximum or a minimum? Well, our parabola opens down, so that means that this vertex is going to be the maximum. It's going to be the top of our parabola. And that makes sense because if you think about it, it's that U shape and the vertex is the point where the reflection starts to happen, right? Last thing we want to find is the y-intercept. And the y-intercept is going to be 0 and then our c, which is negative 15. Oops. Okay, now that y-intercept is beyond where our graph is going to be seen from. And so sometimes that's going to happen where it isn't really helpful when we graph, but it is something that's good to find anyway. And you'll see why I say that in just a second here. All right, so my vertex is 3, 3, so let's go ahead and plot 3, 3. I know it opens down, so I know it's going to be in this kind of a shape. My axis of symmetry is at 3, so I know that too, right? Our vertex gives us our axis of symmetry. Now, something else I didn't add here was the slope, so let's look at the slope. Because remember, the slope's going to help us find our next points, right? So my slope is -2. So we're going to use the slope -2/1 to find one point to the right and to the left. So down 2/1, that gets me my next point. Now I know technically the slope would be different to move to this point back over here. So I would suggest if that feels confusing, just use this slope to truly find the next point and then use the axis of symmetry for the reflection. Because I know if I have a point here, I know the other point's over here. So again, all I did was I took this slope and I said, okay, down 2/1 to get this point. Use the reflection to get that point. So now I need the next points. My y-intercept is very far away here, and it's at 0, -15. So I need to figure out where's the point when x equals 1. So in that case, we do need to find some sort of table type situation. So what we're going to do is we're going to figure out the point where x is 1. And it's really not that hard because all I have to do is substitute a 1 into this equation. Remember, the x's and the y, they're just ordered pairs, right? So if I substitute a 1, I get -2 plus 12 minus 15, and I get -5. Okay, so I go in and I know my point is 1, -5. So that means my other point is going to be right there because this reflects. And that's it. Okay, we're going to do one more example because there is something just a little bit different that you're going to see. I guess this is example 3. So we're going to jump into when you have not only a fraction here as our a, but no b that we can see here. Okay, so we're still going to go through our process. The a is -1/2. Even though I don't have a b there, technically there is one and it's just 0. And my c is 3. Okay, so for opening, it's going to open what my a is less than 0. So it's going to open down, right? My axis of symmetry is going to be -b/2a, which is going to become -0/2 times -1/2. -0/-1. 0 divided by a number is 0. So my axis of symmetry is x equals 0. So that means my vertex is going to have an x coordinate of 0. We just have to find the y. Okay, so that's where we substitute a 0 into the x. So my vertex is 0, 3. Because my parabola opens down, this is going to be the maximum point. My y-intercept is going to be my c. And if you notice here, my vertex and my y-intercept are the same thing. So that works out nice too. Then let's figure out the slope. Okay, the slope is a, so it's -1/2. Remember, that's just going to get us 1 point to the right, 1 point to the left. Okay, so let's go ahead and graph this. So my vertex is 0, 3. My slope is -1/2, so I'm going to go down 1 over 2 to find this point. Remember, my axis of symmetry is right here. So this will reflect over there. Right, so those are 2 points. Now I don't have a y, I already used the y-intercept, so I don't have another y-intercept to use maybe as another point. I already used the slope to find these points. That doesn't work again. So I'm probably going to need to maybe use the table to find the next point. We do want to have at least 5 points. So I could see what happens when x equals 1 to figure out what's in between here. I could do x equals 3. Okay, I could do x is 4. So it's up to you which you want to pick. I would say if I choose x equals 3, I'm going to get a decimal, but that's okay. If you choose x equals 4, you won't get a decimal, but I just don't have room on my graph. So what we're going to do is we're going to see what happens when x equals 3. Okay, so we're going to get that point. So I get -1/2 times 3 squared plus 3, -1/2 times 9 plus 3, -4.5 plus 3 is -1.5. So that means that when x is 3, y is -1.5. So that means when x is -3, we're at -1.5. So what you get is that parabola. And what hopefully you notice is on our first page when we said, let me put this in here. The parabola is narrower than the parent graph if the absolute value is greater than 1, wider if the absolute value is less than 1. And if we look and we compare, let me zoom out a little bit here. If we compare these two, see how this is more of the stretch. It's like it got stretched out. This is a shrink. It's got smushed. Okay, so in this case, our A was -2, so the absolute value of our A was 2, which means I have a stretch situation. Here, my A was -1/2. The absolute value was +1/2, which is less than 1, so I get this widened parabola. Okay, so those are things you should notice as well. Okay, our last example here is a word problem. So take a second and push pause if you need to copy this down. A woodland jumping mouse hops along a parabolic path given by y equals -0.2x squared plus 1.3x, where x is the mouse's horizontal position in feet, y is the corresponding height in feet. Can the mouse jump over the fence that is 3 feet high? So when we think about the mouse hopping, right? So if there's our little mouse and he's hopping, is the height of each of these hops high enough to where he can hop over a 3-foot fence? Okay, so what that means is we've got to figure out the highest part of this hop, or the maximum. If we find the vertex, that can also tell us the maximum, right? If I can find the vertex, then I know how high this mouse jumps, right? So let's take a look at how to find our vertex. Okay, remember that the vertex is the x that we get from our line of symmetry, right? Or axis of symmetry. So I know my x is going to equal negative b over 2a. So we're going to substitute that information. If I look up here, my a is negative 0.2, my b is 1.3. So I get negative 1.3 over negative 0.4, which equals 3.25. Now for my y-coordinate, let's remember x is the horizontal position, y is the vertical. So then I'm going to substitute in. So the y is going to equal negative 0.2 times 3.25 squared plus 1.3 times 3.25. Use your calculator to get all that math done, and you get y equals 2.1125 feet. So what this is telling me is that if I looked at this as a parabola and I graphed it, I'd be over 3.25 and up 2.11, right? And if this is my parabola of the jump, this height is only 2.11 and the fence is 3. So the fence is 3 feet high, but the mouse can only jump 2.11 feet high, right? Now you could also see, how far horizontally does the mouse jump? And if we think about that, my x is 3.25. So horizontally, the mouse travels 6.5 feet. Right? It's not asking us that, but just in case you were asked, could the mouse jump over a 6-foot pond? Right? That's how you would find the horizontal movement of the mouse or whatever you're working with. Okay, so with the word problems, you might need to use one of the pieces of information that you learned about the graph and pick which piece you need to know and find it to be able to answer the question.